Halogenation of alkanes. The halogenation of alkane, the reactants are alkane and halogen acts as group 17 atom ClBr. Products are mixture of alkyl halides and hydrogen halide. This is the side product, hydrogen halide. Conditions light or heat, or it can also be UV. Free radical substitution reaction. This is the type of reaction, free radical substitution. Name of reaction, halogenation of alkane. This is propane. Propane reacts with bromine in the presence of light to form alkyl halides. One Br atom from here, from bromine molecule, one Br atom replace one hydrogen in propane to produce alkyl halide, and the bromine atom can also replace hydrogen at the second carbon in the propane. So the product is alkyl halide as well. The difference between these two is the position of the bromine. This bromine attached to the primary carbon, this bromine attached to the secondary carbon. When halogenation of alkane, when bromine is used in halogenation of alkane, most of the bromine atom will replace hydrogen of the secondary carbon. Instead of primary, it prefers secondary hydrogen. And when the propane reacts with chlorine molecule in the presence of light, it's almost half of the product's alkyl halide, Cl attached to primary carbon, and another half Cl attached to the secondary carbon. So that is the difference between bromine and chlorine, halogenation of alkane. If bromine, most of the bromine will attach to the secondary carbon. If chlorine, half of it attached to the primary carbon, half of it attached to the secondary carbon. Chlorination of alkane. So here, if you look at this alkane methane, this alkane methane, all hydrogens are primary hydrogen. All hydrogen are primary hydrogen. So there's no selection like this one. This propane has two classes of carbon, primary and secondary. But this one, no class of carbon. The chlorination of alkane. Because of the number of products that are produced, this reaction is not very useful in the lab but useful in industry for the production of the various chloromethane. So here, chlorine. If chlorination of alkane means alkane reacts with halogen chlorine in the presence of UV light, the chlorine will replace hydrogen in the methane. So it keeps replacing the hydrogen, and then more Cl replace second hydrogen, replace the third hydrogen, and replace all the hydrogen. The side product is HCl. So if this reaction happen, 47% chlorine replace 1 hydrogen, 20% replace 2 hydrogen, 22% replace 3 hydrogens, 10% replace all hydrogen, and 1% of the side product. So this is not very useful in the lab if you want only one type of alkyl halide. But it is useful in industry because all these products, various types of product, various chloromethane is useful in the production of various products. So halogenation of alkanes is only useful with Cl2 and Br2 selective reaction. So unselective reaction and selective reaction for Br2. Reaction of F2 is too violent, so there's no halogenation of chlorine in the lab too violent, and reaction with I2 is too slow to be useful. Monosubstitution product. Propane reacts with Cl2. So half of it, Cl atom will replace the primary carbon, replace the hydrogen of the primary carbon. Half of it will replace the hydrogen in the secondary carbon. So the product are 1 chloropropane and 2 chloropropane, because this chlorine is attached to the second carbon, so 2. This chlorine attached to the first carbon, 1. With an alkane that have more than one type of hydrogen, a mixture of alkyl halides may result. So this propane has 2 types of hydrogen. Primary hydrogen, this one primary hydrogen, and this primary hydrogen. These are the secondary hydrogen. So more than one type of hydrogen. That's why the products are the mixture of alkyl halides. The weaker the CH bond, carbon-hydrogen bond, the more readily the hydrogen removed. So if you look at here, CH3H, this carbon attached to 4 hydrogen, strongest carbon-hydrogen bond. If there is one alkyl group in the methane here, in this carbon, this primary carbon attached to the alkyl group, one alkyl group, this is less strong than the one with all hydrogen. This is the strongest, less strong. And then secondary carbon, weaker. This is secondary carbon, hydrogen attached to secondary carbon, weaker, hydrogen attached to the tertiary carbon, weakest carbon-hydrogen bond. This is the carbon-hydrogen bond. Okay, this carbon-hydrogen bond, this 3 carbon-hydrogen bond. So tertiary carbon has the weakest carbon-hydrogen bond. The weaker the carbon-hydrogen bond, the more readily hydrogen removed. So this tertiary carbon prefer to remove hydrogen, more readily for hydrogen to be removed. Means this is the hardest. Hydrogen to be removed is the hardest because it has the strongest CH bond. Thus, more stable radical form leads to formation of major product. This tertiary carbon, when it removes one hydrogen, it will become the carbon-free radical. This is the strongest, the most stable free radical, tertiary carbon. For this one, secondary carbon, remove one hydrogen, less stable than tertiary. Tertiary is most stable because it is easiest to be removed, because alkyl group is the electron donating group, so it donates the electron at the carbon. Hydrogen atom can be easily abstracted from the tertiary carbon than the secondary carbon. Less energy needed to break the tertiary carbon hydrogen bond. So less energy needed to break this CH bond here compared to the primary and secondary carbon. Resultant tertiary radical is more stable than secondary and primary carbon. 2,2-dimethylpropane reacts with chlorine in the presence of light. This chlorine, it replaced the hydrogen here, replaced the hydrogen at the primary carbon to produce 1-chloro-2,2-dimethylpropane and HCl. And then this cyclohexane reacts with Cl2. This Cl will replace any hydrogen because all these are secondary carbon. So it replaces hydrogen here in the presence of light, and the side product is HCl. Monohalogenated product may be obtained by using large excess of alkane, which hydrogen atoms are all equivalent. Hydrogen atom attached to the same class of carbon. Because here in 2,2-dimethylpropane, all hydrogen attached to the primary carbon. All hydrogen have the same class. So this chlorine cannot be selective. It cannot select which hydrogen because this chlorine attached to any carbon, it replaces any hydrogen to attach to any carbon. It is still going to attach to the primary carbon because all this carbon are primary carbon. And same goes to this one, all carbon in cyclohexane or a secondary carbon. So the hydrogen attached to the carbon or secondary hydrogen. So this chlorine cannot be selective because it can replace any hydrogen because any hydrogen is secondary hydrogen. So that's what it means by hydrogen atoms are all equivalent because hydrogen atom attached to the same class of carbon.